I'm very grateful for this opportunity. It's very rarely we get the opportunity for two Googlers to talk in the same presentation. And I'm going to cover very similar material in many ways, at least come from a very similar mindset than you heard previously. I'm very aware of what this session is about. It's about sort of organizations that are intermediaries between people who collect geospatial data and end users. And what I want to cover is how do you make that work? How do you get geospatial data to the broadest community possible? So I want to talk in terms of this idea of ambient location, the idea that location data is around us now, used all of the time by many, many users, by many citizens. And how have we got to that particular point? So how does Google make use of geospatial data, or geo as we call it? It's incredibly important to us, it's incredibly important to our users. There are kind of three statistics there, three numbers that I think are really important. First one, 30% of the searches that happen on Google, so someone goes to google.com or google.dk and searches for something, about 30% of those are actually searching for places, searching for locations. So behind the scenes, you're using geospatial data to solve those queries. 41% of internet users use Google Maps. So that's an incredible statistic. And that leads directly onto that next statistic. 1 billion monthly users of Google Maps make use of the Google Maps platform, but coming from about 1 million third-party sites. And that's the number I really want to concentrate on, because I think that's the important one. How do you get to 1 billion users? But more importantly, how do you get 1 million websites to make use of your content, to make use of geospatial data in this case? So we're going to come back to that in a moment. Key to doing this, and you heard this earlier on, is this focus on meeting end user needs. Really understand who your end user is, what are their specific problems, and focus in on those problems so that your data, your application becomes a key component to their lives, literally. It's something that they use, solves a very particular problem for them, and then they'll come back and use it again. And it's beyond probably just a traditional map representation of the world. From Google's point of view, because we're a global company, it means creating a map of everywhere at a similar level of detail wherever we might be. So, as you would expect, you want to be able to get street mapping of major European cities, as you see here in Copenhagen. But likewise, that same level of detail, every street identified, being able to search for address, being able to find particular businesses, you'd find as well in Windhoek, which is the capital of Namibia, or the city of Manaus. Manaus is where England lost their World Cup qualifying game earlier this week. Surprise, surprise. You won't find many English people surprised by that. Again, a similar level of detail even here in the middle of Amazonia. Same capability for our end users to be able to navigate in a particular location. And maybe the most extreme example is this. This is the island of Tuvalu. Tuvalu is about the 220th smallest country in the world. It's only about 5 meters above sea level, and it's probably going to be the first country that disappears as a result of climate change. It's going to be completely inundated by the ocean. But we have a similar level of detail for Tuvalu as we do for Copenhagen, because we need to be able to support our users there who want to be able to not only just see a map of the area, but to be able to interact with it, to use it usefully as part of this kind of day-to-day life. They want to be able to see imagery. This is now kind of a standard capability. Imagery provides you with a much greater sense of place than just traditional cartography. And you want to be able to see imagery from the ground level. What does it really feel like to be standing on the edge of that lagoon, looking at a particular hotel? This is really important, to have this sort of information that isn't abstract cartography, that is very close to people's real understanding of the world around them. And they also want to find information about the places. And these are often places that aren't represented by traditional topographic mapping or mapping that comes from authoritative sources. These are businesses, these are restaurants, these are activities that might be temporal in their nature and don't necessarily come from public sector sources, but nevertheless there's an expectation that they'll be found. And we want to bring into that type of information more of a social element. So in this case, here's the one hotel that you might visit on Tuvalu, and it seems that it's pretty good, so that's okay. That might be somewhere you might want to visit. Where Google is most interested in this sort of data, though, is in supplementing what we do, our business, which is search. So we want to be able to do local search. So given the fact that I'm a particular hotel, I want to find out, okay, where's the nearest restaurant? So you can see there it says search nearby. I can find then all the restaurants that are within a particular distance. Nowhere's very far from anywhere else in Tuvalu. I can find, here's the JY Ocean restaurant, and I can get directions to that restaurant from my hotel. So we need a navigable street database that I can use and interact with. Now, if there was traffic congestion, again unlikely in Tuvalu, but those conditions do exist elsewhere in the world, you'd be routed differently depending upon the traffic in real time. That's based on probe data from people's mobile phones. So this is beyond just traditional cartography. We are interacting with the map, we're using the map to solve particular problems at a particular point in time. And let me walk you through an extreme example of that. Let's say I'm at that restaurant and I've got my Mac with me, but in this case I've forgotten my little dongle. You know, all Mac users are paranoid about carrying these dongles around with us because without them we can't plug into a projector or a normal screen. So here I am, Tuvalu, I've run out, I've lost my projector, dongle, what am I going to do? I'll go online and I'll search for the nearest Apple store. So, turns out the nearest Apple store to Tuvalu is in Hawaii. And I can get to Hawaii based on real-time interactions with airline flight timetables in about 19 hours. Here's the route that it would take me from Tuvalu to get to Hawaii, the nearest Apple store. And when I get there, I can see I can use public transport, linking to that GTFS data that we have in Honolulu. Tell us how long it will take, how much it will cost, very reasonable, just a couple of dollars to get from the airport to the store. When I arrive at the airport, I can pull out my mobile phone and I will see maps of the terminal. I can identify where I am as I move around the terminal. I can identify where the nearest cash point is. I can get my US dollars. I can get a Starbucks. And then on my way in on the bus, I can work out where I need to get off to go and buy my dongle. It's been quite an expensive way of getting my dongle, but there you go. But look how integrated that data is in terms of the activity that I'm trying to do. I'm really solving a specific problem that the user is having at that particular point in time. And that's what we need to focus on when we're delivering applications or delivering services. What's the user need? In this case, it's a consumer need, one that many people are going to use, or many people are going to have as an issue themselves. But we need to think, whatever our application area is, what is that use case? How is the data going to be used in that situation? And obviously, as we progress and we move beyond traditional mapping online to more mobile devices, we begin to perhaps recognize something that we've forgotten, I think, as an industry. We've forgotten that in cartography, less is more. This is the original design for the London Tube Map. And everyone loves the London Tube Map because it takes a very complex system and simplifies it down to something that's easily understood by anyone that's kind of navigating in London. It makes all sorts of compromises about the real geography of London to make that work. We remove a lot of the complexity, a lot of the detail to make a usable map. And I think what we've forgotten a little bit in terms of the mapping that we do nowadays is we put more and more content onto our maps. And actually, what we should be doing is taking content off. Let me give you a quick example. This is the new version of Google Maps. This is the generic version of Google Maps. It's showing me South London, it's showing me where the museums are. But that's the generic version of the map. If I want to say, actually, tell me about the Natural History Museum, the map subtly changes. This is now a map of the Natural History Museum. And I'm going to flick between the two, and you can see that there are changes in cartography. What's labelled, how different pieces of cartography are drawn, depending upon what the subject of the map is. Now, it's early days, but we're kind of investigating how do you simplify cartography in a dynamic way to make the content more acceptable for potentially someone that's using wearable technology. Here, leaving my house and I want to get to my local store, I can switch on my phone, my glass tells me what the local temperature is, and if I want to journey, it's represented not by a conventional map, but by a highlighted, abstract view saying, okay, you need to walk a little bit, then you're going to use the train and it's going to take you 8 minutes. And I want directions as I move around that are set for a particular element of that journey. So as I go along the road, I'm just showing the next turn that I need to make. So the map is very dynamic, it's very abstract for the particular purpose in mind. These are the sorts of thought processes that we need to go through in terms of, okay, given I want to get this geospatial information as part of my problem solving, how do I best represent that? Now, a lot of the data behind the scenes to make all of this happen is collected by ourselves at Google. We have all of these street view vehicles of various scales, from a car all the way down to a backpack that you can carry around with you and go to locations you can't normally visit. But obviously, much of the data comes from public sector organisations. We have well over 100 commercial and public sector data providers that provide us with raw data that we then re-engineer, make available via Google Maps for other people to use. And to be honest, that's a really complicated process. We probably employ more partner team members and lawyers than we do engineers to deal with bringing in all of that content. That's because there are different licensing requirements for different organisations, and we have complicated licensing arrangements as well. But what we try to do is we try to isolate all of that complexity from our end users and from the people that are developing applications. As you've heard before, we try to build an ecosystem rather than building a portal that we expect people to come to use the data from one location. That billion end users from 1 million websites comes from APIs, comes from pieces of functionality that a developer, that a programmer can get access to, that gives them access to rich data sets, gives them access to quite a lot of functionality to be able to get directions and to do local search. But it also abstracts them and it isolates them from all of the complexity of the licensing that they might have had to deal with if they went to each organisation in turn. We provide those APIs on most of the mobile phone platforms and via the web. So our developers, who are not our end users, who are the interface to our end users, are using these as a way of getting access to the data. And that's a key point, to build a platform rather than a destination. Now, 95% of the sites that are out there, be they websites or mobile phone applications, actually make use of the free API. That means there's no direct relationship between those developers and Google. We don't know who they are. We don't know the apps they're building. We don't know necessarily how many users they have. Now, that's difficult if you're a public sector organisation and you want to measure how successful uses of your data are, because, well, we don't have that information. It's much more loosely coupled than that. So the developer is unknown to us if they're using the free API, and also, therefore, the end user isn't really known to us. But that is the architecture of the web. That's how the web works. It makes it very difficult for people to build successful applications if you want end users to register and provide detail. End users aren't really interested in doing that. Here's a controversial subject. GIS guys are great. Hey, I'm a GIS guy. But they're the last people that you want to design your website. They're the last people you want to provide a user interface to normal people. Because your GIS developer is really happy with a user interface that looks like this. If anything, they'd like more buttons than that. And actually, your end user doesn't want that. Your end user may be looking for that one specific task. You know, it might be somewhere wearing those glasses, just needs to know that you've got to walk 150 meters and then get on the train. You don't need a complex user interface if you're looking very specifically on a particular use case. Here's the example of when you do let your GIS guys build your web interface. That actually is a website, although it looks like a desktop GIS. You've got your traditional table of contents there, you can switch layers of information on and off. That's too complicated for normal people, way too complicated. Think specifically, what's the use case? Okay, it might be finding out about local schools. So then you build a user interface that is just about local schools, or more, maybe we'll look at this in a minute, you make the data available and let someone else build the application that looks for local schools. Or if you want to provide a tool to publish data internally for your organization, make something easy. This is an example of Google's map engine. This is a very simple tool for you just creating a map and sharing it. So here I am digitizing the location of this particular event. I can get online, I can use the OS data that's in the UK, for example, as a backdrop, or here in Denmark we use the data in Google Maps, put the location of a particular place. Then I can just say, right, I want to share that, and you share it in the same way that you would share any other document online. You can choose to share with individuals, or you can choose to make it publicly available. Anyone can then access it. And if you choose to do that, they can then just cut that piece of code in the same way that you would do if you were watching a YouTube video and put that into your web page. Now, these are Google's tools for doing that, but you could develop these same tools yourselves using whatever platform technology you've come to hand. But the key thing is to make it simple and to make it work in the same way that most other applications online work today. This is the point I really want you to focus on. I think for too long we've been thinking about the way that we distribute geospatial data is we build a portal, we build a destination, and we expect people to come to our destination to get access to the data. Well, that's fine if they know about your destination, but in reality, probably they're not going to. A better strategy is to build a platform so that your content, your information, is spread as widely as possible, across as many different websites as possible, for as many different user communities as possible. So it's easily embedded in other communities' views of the world. So don't build a destination, build a platform that can be then the basis of other applications. And you don't need to build an API. You don't need to have a personal geek that's going to be there supporting you, creating an API that you then have to maintain. You just need to be a good web citizen. That means publishing your data so that map features are what we call endpoints. They're somewhere on the web that you can identify uniquely, i.e. they have a URL or a URI associated with them. So I keep coming back to that same place, that same location, and I'll always find out about that particular school or that particular lamp column. There'll always be a map or the attribute data associated with it at that particular URL. That also means that it's crawlable. Websites can find that information directly without going through a portal to find it. The benefit of that, and this is an example from the borough of Richmond where I live in London, is that it's then easy to share because you can embed those links, those URIs, into a web page or an email. So I could say to my friend, you need to go and take that old fridge to this particular recycling site. And I can copy and paste that URI into an email, and that email is then shareable. You can't do that if the information is sitting behind a portal through various layers of metadata. It's not possible to share that individual feature in the same way. So think about, whenever you're designing these systems, how do I share my content? How do I make sure my content is shareable to other people, other organizations in a simple way? And finally, I guess, this is a picture from the London riots in 2012. And these were people that got themselves together and started cleaning up their neighborhoods after the riots. And this didn't involve the local municipalities or the local council doing anything. These people organized themselves and went off with their brooms and went in, tidied up. You, as organizations with public sector information, could actually get much more benefit in terms of people sharing and making applications, building that ecosystem, by actually doing much less. By just making the information available, being a good web citizen, giving you information URIs, publishing it on the web using traditional web techniques, and then allowing that ecosystem of other developers to build the apps that sit on top of that. Now, we can help. As I said, there's a lot of technology out there. By no means is Google the only player here at all. But we do offer what we call the Public Data Program. If you want to host your data using Google's infrastructure, and if you're a public sector organization, you can do that free of charge. You don't have any exclusive arrangement with us, but we will host the data on your behalf. We will look after managing all the servers and everything, and you can share your data using us as one of those many channels and those many different ways of getting your information as widely distributed as possible. So the key to success then, being that middleman, is to build the ecosystem to support as many different users from as many different communities as possible. Spread your data as widely as possible, then you'll get the maximum benefit. Thank you very much. But I'm sure we'll be happy to take any questions. No, I will take questions, I promise.
One comment.
Yes.
Every time I zoom into Google Maps, I seem to get the view in the center. I have to move the map again. Is there any plans? Because like every time you zoom in, the view gets centered.
I think that's how it's meant to be.
Okay, so you no, okay. Okay.
It zooms in on where you click.
Yeah.
So if you click like to the edge of the screen, then
Yeah.
that will zoom into where you've clicked.
Okay.
If you click in the center, it will zoom to the center. Or if you use the plus and minus at the side, it will just zoom into the center of the screen. Yeah.
Okay, man. Thank you.
Okay. No more? Oh, there we go.
I was triggered by your remark about how governments would like to have a metric on whether their data is used or not. And I suppose you have to have a metric as well to your upper management on whether your Google API is used at all. And I know it's used, of course.
Yeah.
But is there any, how do you deal with that? Are you having a sort of, if there are so many API calls, there are so many users behind that API call, or what sort of?
Well, I mean, we've come to terms with the fact that we'll know the number of users, we'll know the number of unique users, and we'll know a very vague geographical distribution of those. But we actually aren't that worried about how they're using it, just its use. And you know, ever increasing amount of use is important for us as that level of metric. That you then have more qualitative sense of how people are using the data from the applications that you see being developed. So you have the quantitative sense in terms of just the mass number of people using the application. Then it's more qualitative in terms of the different types of use. And you know, we're not at all interested in categorizing, you know, how many people are using it in utilities or how many people are using it in retail. We just want to get as many people using it as possible.
My name is Poole. I'm the current chairman of the OpenStreetMap Foundation. I'll explain what that is a bit later on. Besides being the chairman of the board, I'm also a member of our license working group, and licenses are always extremely popular. And I will try and leave enough time so that we can have some questions. OpenStreetMap is this absolutely, totally bonkers, crazy project that Steve Coase started in 2004. We're going to have our 10th anniversary this year. And one of the things that I want to do in this talk is try and clean up some misconceptions about OpenStreetMap, and later on touch a bit on reuse of public sector information in our project. Now, one of the problems with OpenStreetMap is that we have a name that is not really true. We do not do street maps. It is a data collection project, a crowdsourced data collection project. But unluckily, we didn't think about that 10 years ago, so we're stuck with this name. Now, you can actually make maps with our data. I hacked this together yesterday evening, so even with a tie, I'm fairly nerdy, like most of our contributors, or more conventional now. Now, one of the things people have a misconception about is that they think we're a direct competitor with our dear friends from Google, but we are not. Essentially, the core project simply generates geodata, collects it, imports it, and so on. And we have a whole ecosystem of other organizations, companies, individuals, other organizations, non-profits, that take our data and do stuff with it. So the heterogeneous look that and the impression that you get of OpenStreetMap is actually on purpose. Now, how many are we? There's about 1.6 million accounts on our central system, and about 400,000 people have actually contributed to our data. The OSM community is the important thing. The OSMF is this thing down here. What we do is that we support the project, we run the infrastructure, and we are the formal licensor of the data. It's a purely volunteer-run organization. We have exactly 0 employees. We have an external accountant. That's about the only person who regularly gets money from us. And you should notice all these people up here are smiling. This one down here is at least indifferent, because it's not an easy task. And as all good Web 2.0 social networking organizations, I have to show a graph which points deeply upwards. There is some interest in this thing because, oops, sorry. I don't know how many of you know that Wikipedia has had this issue with their contributors dropping off, which I personally don't think is a big problem because it's part of the nature of the project that is fairly mature. And so my take on this is, well, we're not at that maturity level, we are still steeply going upwards. Okay. One of the interesting things about OpenStreetMap is, while we are a large reuser of open public sector information, the big difference with OpenStreetMap is that you actually get open data out. And that is a big differentiator to essentially everybody else who at least who's not himself an open data producer. And we have our user contributions and open data licensed in some form which is compatible with ours. that we use. Now, one of the things that I want to point out to is that there's not just one way that we use open data. Naturally, you can use OpenStreetMap. Job showed a nice application with OpenStreetMap tiles below and using other data to generate an application. The other thing that we do ourselves is use open data as reference. So not necessarily integrated into our data set, but use it for quality control and similar things. I have an example here, which is fairly nice. This is Nottingham, and there's a open data set of the street lights in Nottingham. And the person who generated this used these street light positions to determine whether we were missing a road or not, because there's no open road data set. And so where there's yellow, there seems to be a problem. Perhaps there are different lights than normal street lights. That's actually an indication that you should go there and investigate. Now, we tend to have this problem with the open data community, that they sometimes come to us and go away fairly miffed because we didn't really want their data. And that is something which I want to try and explain in the couple of following minutes. OpenStreetMap is all about community. We want to build our communities because in the end these are the people that build our data and maintain it. Where there's no community, even if we have data, that data is just going to go stale and be dropped. The other thing is, I'm sure you're all proud of your data sets, but most of the time they were designed for a specific purpose and may not really fit well into what we need in OpenStreetMap. Good example is the Korean land cover database, which is nice. It's a generalized data set of land use, forest, fields, and so on. The problem is that it has tolerances which go into the hundreds of meters. And a typical land use polygon in OpenStreetMap will, depending on how it was generated, if it was generated from aerial imagery, it will have tolerances around about a meter. And so such data sets have been imported into OSM and have not really worked well. The other problem is the OpenStreetMap data model. We do not have layers. We are very non-GISy in that respect. And that means that all our information can be tied to the same object. So you might have this building here, might have a cafeteria in it, and this might all be tagged or attributed on the same building polygon. So when we import data, it has to be processed so that it works with our model. And the other thing is, naturally, if something goes wrong, you potentially mess up the stuff that's already in there. So conflation, merging external data with our data sets is one of the big things that you have to do when you import. Now we have an original thing. Tiger is a data set. I know Ed's laughing now, naturally. Tiger is a road data set, public domain, generated by the Census Office of the United States. It's insofar very nice because it should essentially cover all inhabited places in the States. And when OSM was starting off in 2007, there was this big void called the United States. Big country, really only the coasts are heavily populated around the big lakes. And people thought it'd be a good idea to import this into OSM. And they took the 2005 Tiger data set and put in an awful lot of work, I have to say, and it came out rather wrong. Now there are areas where Tiger is very good, but there are areas where it is very, very bad. And this is not a completely random location, but you can see there's satellite imagery as a background. The white stuff is the 2005 Tiger data that we imported, and the yellow stuff is actually the 2013 data set. Interesting enough, the 2013 data set is here actually worse than the 2005 data set. And that was really damaging. Importing this sounded like a good idea, but it was really damaging to our community. Because on the one hand, people are motivated by voids. At least people that participate in OpenStreetMap say, oh, there's virgin territory. I can fill that up. Suddenly, all of the US was covered. The other thing was, fixing stuff tends to be harder than creating it new. And untwining and unwrapping this is really difficult. I should point out that Ed's company, his employer, has a patent since 2 weeks or so that actually explicitly mentions fixing Tiger data. By the way, this is fixed now. I spent about a morning fixing it, so it's no point in going back and looking at it. So this historically has set the scene for a slightly, not quite unproblematic scene with respect to imports. Now what will not work? As I said, filling of empty space typically does not work. Stuff with questionable quality typically does not work. Very important, things that are odds with our on-the-ground rule will not work. One of the principles of OpenStreetMap is that we actually go out and survey stuff ourselves. And it may be very interesting that you have this authoritative list of street names. If they're not on the street signs, we're going to use that what's on the street signs. And we will take note of the official street name, but it will not be what we primarily use. The worst thing, and I have to say I've operated 2 SMEs in my professional career, they are incompatible and homegrown licenses. Please, please use something that is well known. We cannot afford, SMEs cannot afford to employ counsel to go after every funny thing that you thought up. And last point here, not following our import guidelines is sure to cause issues. The import guidelines are essentially the common wisdom of 10 years of OpenStreetMap. And they're there for a good reason. Now what will work? Point data will work typically, small scale features, administrative boundaries. They are included in the larger category of things deemed important that can't be surveyed. Essentially no admin boundaries these days can be surveyed, they're all electronically only. Compatible licenses, already said that, and please follow the guidelines. Now, what is a good example of something that we would really be interested in? Addresses. Addresses are important for door-to-door navigation, for other applications. They are relatively slow to survey, so while we are adding multiple millions per month, it's going to take a lot of time till we have all of them. And I surveyed the house numbers in my village when my daughter was sub 1, pushing the pram along going, number 1 is right, number 2 is left, and so on. But, you know, without a big increase in fertility in Western Europe, that is not going to really help us. The availability in OSM levels the playing field, because naturally all our competitors have a couple of decades of more time to get these addresses in. And one of the nice things about addresses is they're useful even if we do not import them into OSM, because you can geocode on them, etc., even without them being in the dataset properly. Addresses have the problem, and that's why they are not in general available as open data, because there's a perceived monetary value. I don't know how large that monetary value is, but I know that we are driving it down. So why not give us the data now before it's not valued at all anymore? Yes, I mean, if you wait long enough, you know, your data set is simply not going to be worth anything anymore. But because addresses are important, there have been a number of activities around them which have increased over the last couple of months. We have projects in the wider OSM ecosystem to gather metadata on addresses, so who has free data sets, how are they licensed. There is a global but currently very US-centric collection called openaddresses.io. There's a similar project for France, and I have an unannounced one for Switzerland. And there are many more activities at a local level and national level. We've had large imports in Denmark very early on in 2009. You will notice that we have a slightly less active community in Denmark, and I would attribute it exactly to this import. We have had a large import in New York City just this year, and there's an ongoing one in the Netherlands right now, which is nearly completed. That was about 2 weeks back. I believe that they only have a couple of 100,000 left. So, coming to the end, I have some links here. I'll put the slides online somewhere, or I don't know whether you intend to do so. I want to point one thing out. Please spell our name correctly. It is an absolute pain every time somebody gets it wrong. So, questions? Everybody's shocked. Ed?
So I had to ask the obvious question about your license choice, and very particularly the viral share-alike element to your license choice. Would you like to explain?
Explain. Well, I didn't choose it. But it was part of the thing that I did in the license working group, was to actually finish and give the project a bit of closure, because it was a project that had gone on for 5 years. The license that we've chosen, ODBL 1.0, actually, as it says, has a share-alike aspect. Some say it's very strong. I would probably say it's not so strong. A lot of things can be done. The main reason I believe that we currently still have a share-alike license is what the community doesn't want to happen is for somebody to take our data set and produce the new and improved version without giving that new and improved back bit. That's the prime motivation. There's some nasty people, which I don't belong to, which says it's actually the anti-Google provision. But even Esri is using our data currently, and they're completely within our new guidelines and the license. And so I think there are some restrictions. There are some things which we have not really clarified yet. There are some grey areas, but that is in work. And so right now, I'm not unhappy. I'm putting a different hat on. One of the jobs of the OSM people is looking after the community. The one thing we don't want to do right now is change the license. Again, it was 5 years of pain. So give us some time, perhaps down the road, we'll go to a more liberal license. There is one thing that I have to say. Typically, if you're in the public sector, your employees get paid to produce the data that you're providing openly. Please don't forget, our contributors have not been paid. Any more questions? Yes?
In your talk you mentioned your competitors.
Yeah.
Who are your competitors?
Ah, easy. TomTom, Nokia, Google. The 4 global players. At a local level, I don't think there's more cooperation, and that my professional background is the telecom industry. And in the telecom industry, people buy from each other, from the worst competitors, and so on, and get on reasonably okay. So that doesn't, saying that somebody is a competitor is not a negative. Yes?
I have a second question.
Yes, Rob.
Are you looking at quality indicators for crowdsourced information on part of either the data set or the metadata update?
There is essentially every year at least 2 to 3 university projects which look at that. I run, for Switzerland, I run a quality assurance site, and there's tons of such things. They are typically not initiated by the foundation, but they're actually useful numbers that everybody likes to have.
There are some standardization initiatives adding quality aspect.
Okay. I'm unpopular enough in the OSM. Suggesting something like that is just... Okay.
If somebody gave you $1 million, what would you do with it?
It's a movie quote.
Not my data. There's, I think, 2 things that we would do, particularly on the operations side. We are slightly misusing the volunteers that we have. So we would probably turn that into a more regular thing. There is work on our website when nobody has been particularly motivated to do it, that we might finance out of that. Particularly beta mapper support. And we have our humanitarian OpenStreetMap team, which does a lot of good things, which could be supported as well. But right now, the problem with the 1 million is we're now in a very enviable situation. We are not dependent on anybody. Our budget is so small that, in fact, most of it is still covered by the people that are actually putting the work in by the mappers. So there is this danger of going from this very independent and we don't care situation to the problems Wikimedia has with 200 employees and really having to meet ends match every year. And that would be particularly unpopular. Going a bit in that direction might be doable.
I have an ulterior motive for the question. So what I get from that is there are things that you could do. Well,
yes,
my guess is actually that $1 million wouldn't actually be anywhere near enough to do some of what you want to do anyway. But let's see.
It depends. It depends. I mean,
yeah, true. If I had it, of course.
Yeah.
You're the first person I gave it to. But the share alike thing, your cultural soulmate in open corporates as a share alike license there. And if you want to take the open corporate database, those are the database of millions, tens of millions of registered companies around the world, which you can have for free. People are paid to curate that. But if you want to take that data and not share your improvements, then you pay for it. So there is, so they have a small number of clients who don't need quite a decent sum of money. So your share right license actually could be a way of getting money.
I want to point out, the share alike only kicks in if you so-called publicly use whatever you have done with the data. So if you want to use OpenStreetMap in-house, give it to contractors, have contractors do something with that, share alike just doesn't kick in there. I would be relatively wary of asking for money, because since the beginning it's been a project where we said commercial use is okay. Actually, people are always very proud if they see a new application using OpenStreetMap, and then now and then there are tensions. I was talking to Ed about this this morning. I don't take it quite so seriously. I think in general the community is quite friendly to commercial use. There was a historic event with one of the companies the founder of the organization founded, which may have made things more complicated than they should be. But if somebody wants to use our data and keep it in his proprietary project, as long as he doesn't violate the license, okay with me. More questions? I'm here till late tomorrow, so if anybody wants to discuss things with me or do license chat, which I'd rather not, then please try and get home.